Hello, everyone. Good afternoon. I see that it's really hot topic nowadays. Who has slow up and is working on improving the performance all the time? Good. Because today we will talk about performance, but not this perfect one, but this pretty bad one, and how to improve it. So every developer knows this feeling when a client comes and says the performance is really bad, or the performance is not satisfying for us. Do you know that feeling? At least once you experienced that in your dev life? Yeah, you got the idea. So why am I even there to talk about that? So I'm a software engineer since 11 years. I did mostly coding in JVM, so it's not really popular on this conference, probably. But I also do the C# coding right now, because I work on an e-commerce project. I do Scala coding there, C# and JavaScript. I was involved in some pro bono projects like Giggers Carrots and Code Carrots. I even have my students here. So let's talk about you and your awesome app that you just finished. It has clean code, it's solid, it's modern single-page application. It uses all the hipster frameworks from this year. It's simply beautiful. And if there is any award of golden computer, you would probably get it. But honestly, nobody cares, because every screen loads 4 seconds. And 4 seconds is actually pretty tolerant, because for us, 2 seconds is pretty bad, because in e-commerce, customers don't forget and forgive. Sometimes customers just say it feels slow. We will talk about that in a minute. Because performance is really subjective, right? If you are working on the application for your grandma to upload the pictures, the performance standards will be probably a little bit different than if you work for app for millennials, right? Because they are eager to get everything at this moment. But the good news for developers, for us as engineers, is that you can still measure most of it. So where to start? Client comes and says, performance is bad. You roughly have 2 ways. You can start digging into those workarounds of backend, or just tear this teddy bear apart and look under the rainbow. So the first tool that we use from time to time, and I recommend typing your address of your application there, is PageSpeed Insight. This is Google tool, I believe, and they show you what is bad about your performance, and they give you the score from 0 to 100. And the funny thing is that PageSpeed has only average score in PageSpeed standards, so they can do better. So this is the example of the report that you may get. That, for example, this is a suggestion that you should reduce the server response time, or you should minify the JavaScript and CSS files, etc. So you have ready-made fixes that you can apply in your application. Pretty cool. Another fancy tool that probably every developer uses at least once is developer tools in browser. And there is one thing that probably half of you never used, which is slowing the internet connection. So for example, you can simulate how your application is working on fast 3G, slow 3G, or if you go offline for a moment. This is really useful because most of tests are happening in the office, where you have great Wi-Fi, you're connected to the good internet, but you never know what are your customers experiencing when they go, for example, hiking in mountains, right? Unless you go and test it there. So if we talk about developer tools, there is also performance tab. And this one is a little bit messy, but the great thing about this tool that I really like is that it takes snapshots of the current look of the page. So, for example, I tested meetup page, and as you can see, after almost 2 seconds, there's absolutely nothing on the screen, maybe one dot and some shadows. Then some important information pops up, but still it's not a complete page. And somewhere after 2 seconds, you get almost all the content except the GDPR information. So this is kind of like lazy loading. So you get chunk by chunk, and you don't get all the page at once. But for example, the DevConf has different approach. So it takes a couple of seconds to load the page, and you can see this loader all the time, and then you get all at once. So it's voila, here you are. So it's your decision. What do you want to serve to your clients? If your clients are usually using good Wi-Fi, or they are hiking a lot, or they are grandmas and they don't really care because they hit the page and they go make some tea and come back after 15 minutes. I also recommend the monitoring. Automation is always great investment at the beginning, but then it's cheaper in the long run. For example, load and performance testing. There's a couple of tools for that. We use Gatling, for example. And here is the sample scenario for Gatling. So you can type it this way, because it's all in code. That you introduce a product into the database, and then you check if the products are loaded, and if it gives the 200 status. So this is like really plain and simple scenario, but you get the idea. You may test whole your application, whole your API this way. And here is the report. We don't really want to see the red color here, because it means KO for your application in some scenarios. So the more green, the better. If you don't want to spend too much time investing in automated tests, you may simply do some manual stress tests from time to time, especially if you want to introduce some performance improvement, then to have some benchmarks and to have some numbers to compare with. So for example, here you have the loop that queries 10 times products on your localhost server. And here is the sample of the report. So you grab those numbers, then you introduce the change, you run it again, and you check if those numbers are better, worse, the same. And it's really important that it's on the same environment, because environment really matters here. So if you do the test on localhost the first time, you should keep it every single time this way, or do all the tests on the production, etc. Probably not the tool that you're using every day, but I found it useful a couple of months ago. This is the JConsole for JVM. And we introduced some change that started killing dev environment. Just randomly from time to time the machine was killed. And we didn't know what caused that, which endpoint caused that. So we started JConsole on our localhost, and we called the API. And we found out that one endpoint used 1 gigabyte, which is pretty bad because our limits were like 700 megs. So you know now why the machine was killed. And if your idea after seeing this slide was to type JConsole in Google and go to the documentation, don't, because the documentation is really crappy here and says absolutely nothing. This is the documentation that you want to avoid in your project. The tool that we recently started using is Prometheus. Basically, anything that can be presented in time series can be drawn by data gathered by Prometheus. So you can create the chunks of data, you can group them, you can specify the endpoints. So for example, for us, if we query products, we don't really care about the product ID. We just want the average speed of the call for product endpoint, right? So we can group them. But you can also have every separate call presented here as well. And also really simple and plain database calls because it shows you the time. So if you suspend, or you can clearly see that some endpoint is really slow, but you don't really know if it's the API itself or the database, I recommend start typing the query into the database and see how much percent of the time needed to prepare the result is taken by the query itself. All right, so we have the information, we have the measures. And let's say we found out that the front end is a problem. So what to do to speed up the front end, or at least make it appear faster? First of all, cache. Cache whatever you can, because it speeds up a lot. So store as much as possible on the content delivery network, because it has data centers across countries and continents. It delivers the data to customers locally, and it increases the speed, of course. As you can see here, it's like more than 3 times faster on average. Probably if you deliver across continents, it will be even faster. There are a couple of tools for that. By the way, there is really interesting page which is called Stackshare, where you can compare the tools, where you can see the alternatives, you can see the pros and cons and who is using the tools, and you can also register there and say what you are using in your project. So for example, from those tools we use the Cloudflare, and besides the Cloudbleed, we didn't have any trouble with that. Talking about cache and frontend, we couldn't avoid the topic of images and videos because they can get pretty heavy. For that, we have the Cloudinary, which is just the CDN, but for images and videos. And it's used for responsive and scaled images. It can be also used for the storage, or you can store it somewhere else, in Amazon or somewhere. And it allows you real-time manipulation of images. For example, those ridiculous examples that you can flip, you can rotate, you can even, I don't know, do the eclipses with your images, especially if you are backender with all your heart and you hate CSS and you don't want to do that with the CSS, then you can just specify that in the link and the Cloudinary will do it for you. And you've probably heard that CSS and JS should be minified, should be non-blocking, shouldn't be concatenated, and should be compressed, right? Make sense? Great. We use Webpack for that. It handles gracefully all our dependencies. But there is one problem. That applications are growing bigger and bigger. And I believe it was Philip's presentation where he got this picture with the black hole and then node modules that are like a couple of times bigger. So this is the problem. So if you want to load all at once, it will be extremely heavy and it will be extremely slow. So if you want to see where you have your bottlenecks on the front end, you may measure the size of the dependencies. So for example, this tool is called Webpack Bundle Analyzer. It's installed with NPM or Yarn. It generates the JSON file. You can dig into data if you are a big fan, or you just run the interactive tree map on the local host, and this GIF presents you a sample of the final solution. Because it visualizes the content of your bundles. So the big chunks are the ones that are heavier, and small chunks are those that you don't need to care about right now, because probably one day they will become bigger, but not yet. So you only care about those big chunks, and you want to make them smaller. So dynamic import is an interesting idea that was created some time ago. It's about importing modules when you need them, and not all at once. So basically there are two scenarios. One is preload, when your resource will be needed during the current navigation. So for example, you're on the product page, and the stuff that is absolutely crucial is the images, price, a description, and the name, and some delivery information, right? But for example, suggested products are not so crucial right now. So they can be loaded after some time with their dependencies. So this is the preload, because you're on the same page, but you load some of the data after some time. So it's asynchronous. But you can go one step further and prefetch the resources that will be needed in the next step. So if you are on the product page, and we are optimists here, so probably the next step will be the checkout, right, and the shopping cart. So you may load everything that will be necessary in the next step. And you can do it manually in the code, or you can ask Webpack to do that for you. You can configure Webpack this way. Content placeholding is a kind of lie. So it's a trick that you're lying to your customer a little bit, but it makes the customer happy, basically. You know that probably from Facebook or other popular applications. So what you can see when you're offline or almost offline, so we are, for example, on a slow 3G, is the draft of the page. You don't really download any feed yet, but you have the impression that something is happening. You don't see the empty page with the loader, but you get this nice frame instead. It gives you absolutely no value because you cannot see the feed yet, but you have the impression that it's nice because someone cares about you. We use that as well in our application. We use that for shops, for example, where we load the cover photo and the list of names of collections. So you get the feeling that something is happening, but this huge amount of data is still being downloaded and built on the front end. Some cheat, but useful. Optimistic update is also some trick, but it needs to be used carefully, because it only makes sense when something is not really important for your business logic. So for example, Facebook again, or rather Messenger. If you send the message to your friend and you get offline because you're on a train, then this message will be delivered when you catch the internet. But if you refresh the page, it will disappear, which means that they create the impression that it was already sent, but it was not. And if this message won't be delivered, probably it's not a big deal for you, unless it's some crucial life-saving information. but still you get the impression that it was sent and the performance is a little bit better than nothing or empty page. And we use that, for example, for likes, for favorites. So if the customer hits the heart, we show immediately that it was added. So it's like the heart becomes red, even though it may not get delivered to the backend. I mean, we do everything that is possible to get this message delivered, and we retry if it fails, but we don't wait for the response from the server to show that it was added to favorites. Some small lies, but customer is happy with that. All right, so let's move to the backend, to the engine of our application. I'll talk about REST API because this is what I do on a daily basis, and this is where I spend most of my time. The first one, simple, but still lots of developers forget about it, paging. The most popular skip and take. I measured some responses time, and for example, for 20 products, and we use Elasticsearch, so it's pretty fast. It took 20 milliseconds. For 1,000 products, it took 6 seconds. So you can see the difference, and you don't really need those 1,000 products when you load the page. And it was the Wi-Fi. With fast 3G, the 20 products took 700 milliseconds, and I didn't even try to download the 1,000. So you can see that it's huge difference when you grab only some data that is necessary for the current page, current look. But please, 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 don't use paging on the front end because it kills the conversion rate and it's not really user-friendly. So use lazy loading and use paging only for the API. Amen. Another thing for the REST API, but not only the REST. Actually, it's true for any API. Send only necessary information. For example, this is the product look on the list of products. And it's only 10 kilobytes for 20 products because it's only the image, the name, the price, and the brand. But for example, this view of the product is 3 kilobytes per product. And we are not talking about images because images come as addresses and not as data. So it's pretty light anyway. But you can do the math and see that it's almost 6 times bigger when you try to download all the products as they are on the right. So try to minimize the data where it's not necessary. Because here you need this information when you present the product. You need the sizes, the variants, you need the description, all the images, etc. And if you present the list of products, you need only some basic information that is pretty light. Also, consider excluding expensive data to additional endpoints. For every application, expensive data is something else. For us, it's product availability, because sometimes we take it from the third parties. And when you want this information for 20 products, it may take seconds. So what we did is we excluded the info about availability to additional endpoint. So we serve the products immediately, and then we download the information about availability of the product. Also consider zipping responses. In 99% of scenarios, it makes sense. It's some cost on the backend, on the front end, but still, it's worth trying. And also caching on the REST level. You may find different examples. Here I have 2. The backend says, it was last modified on this date, and the front end then when asking again, asks if it was modified since, and gives the same date. But you can also use the token, and if the front end asks about the data and sends this token, the backend says it was not modified, and sends 0 content, which is extremely fast, because it's no content. No content has best performance ever. And the database. Anyone ever used indexes for databases? Great. That's awesome. Because you should use indexes wherever it's necessary, and there are tools for that. So you don't need to think about your bottlenecks. There are tools that will do it for you. Probably there are even apps that will do it for you. For MongoDB, there is Performance Advisor, and it's for extremely lazy developers, because if you hit this more info button, it will even show you the query, how to build this index. So it's extremely easy to improve performance in no time. Update smartly. This is scenario from last 2 weeks, where we replace to update, because we updated only one field, but instead of updating the field, we replace the whole document for product. And if you have lots of documents, then it will become really slow. So we improve the performance from days to hours. So I really recommend this one. And some of those scenarios feel easy or obvious, but believe me, in real life products and projects, people still do that. Duplicated data. If you're not with the monolith anymore, you probably know this concept. It's still a little bit controversial, and it should be used when you have mostly GET requests, so you store the data in many places. So you read more often than you write. When your resources are used everywhere, for example, for us it's product. I cannot imagine any page from e-commerce without product. Maybe, I don't know, terms of use or something, but any other dynamic page is connected with product somehow. And if your performance is really important and consistency not 100%, but for example 6 sigma, then it probably makes a lot of sense to duplicate the data. So we're getting closer to the end, to the summary. First, observe and measure. You have tools for that. Create benchmarks, show the numbers to your team, to your manager, to yourself, and measure everything. I know that performance is subjective, but still, you may measure most of it. Find bottlenecks. Fix a little bit. Don't stop development for 3 months, because we are now all performance engineers, and we don't deliver any new features because we are improving performance. No, just fix a little bit, create one index, improve one API call, I don't know, change one front-end page that it appears faster, and repeat. Observe and measure, find bottlenecks, fix a little bit. Observe and measure, find bottlenecks, fix a little bit. Thank you very much.